Good morning to a lot of my friends who are quite regular to our knowledge series, which is free series that we've been doing since 2019. So far, till today, we have done 93 webinars, mainly on knowledge series that we have conducted on various subjects. Okay, so I'm happy that we have almost covered 19,000 odd people with this 92 webinars. So we do this mostly on Friday and Saturdays. We will be coming out with another series from Focus and FSAI, Fire Safety Pe Charcha. So it's going to be no presentation. It's going to be a panel discussion where we will be calling the chief of fire chief from respective states. So we are starting from Delhi, where our fire chiefs and a lot of experts will be joining, and we'll be discussing how do we contain the fire in a building. So fire, of course, it does happen, but how do you contain the fire? So Fire Safety Pe Charcha will be, the series will be launched from 1st of July. So we will be moving from Delhi to Bombay to various cities. So let's see how many people participate, but it will be a wonderful series to understand how do we contain the fire in a complex or in a commercial establishment.
Good morning, all participants.
Good morning. Good morning. Good morning.
I wanted to show you,
I wanted to show you. I'm going to unshare. There's a very interesting report that has come out by the National Institute of Disaster Management, NIDM. Okay. Again, what they're talking is the learning lessons for urban safety. They have pulled out many case studies of various fire that happens in India, and what are the losses, and ultimately what was the cause for these fire. So 90% of the case study says it's all due to electrical short circuit. And also they talk about what is the learning. And this is almost, how many pages is this? 109 pages. It talks about the number of deaths in each city. And another interesting that I read in this article, they talk about the incident of 4 years, that is 2014 to 2018. If you look at here, the Maharashtra recorded the highest, Maharashtra and UP recorded the highest number of fire.
probably the method of, the reporting is efficient there.
Yeah, in Maharashtra and UP. Yeah, generally the report, we do not have a proper recording of these incidents. Some are recorded, some are there is white papers available, some are not. And there's another interesting number of fire calls that Delhi fire has received is almost 31,000 in 1 year. 31,000 to 60, almost how much is almost 1,000. 11, 12, almost 3,000 to 4,000 fire calls in a month. Anyway, I just wanted to share while we talk about the losses due to electrical fire. Good morning once again. Good morning, ladies and gentlemen. Very happy to see you all once again majority of our participants are quite regular for our Mr. Gopakumar's free knowledge series on electrical fires. And my name is Dominic. I've been in this fire industry almost 35 years now. The past president of FSCA and the founder of Fire and Circulation of India, and been involved in almost 800 to 900 across India. So I would like to introduce the sponsor, I would say, initiative of this series of webinar is Cape Electric. You know, in 1998, such protection devices were very new in India, and Cape installed first SPDs for protecting industrial electronic system, DC combiner solution for solar PV, which were unknown once when Cape delivered outdoor DC panel in 2002. And today, in 2022, they've innovated the new way of auditing the self-audit, I would say, self-appraisal of your facility. They have introduced Solve, which is a software, a safe operating of low voltage electricity, a digital platform to understand how your building is safe. Leading the market with right solution is their motto, and the team in Cape Electric are continuously training and providing a end-to-end solution from design to implementation, rather than just selling a product for customers' need. Most of us know about Gopakumar, who is the member of NBC, IEC, and BIS. And he has done over 1,000 training in various countries on this subject. And he has done a lot of case studies, over 1,000 of electrical accident analysis. Recently, he has published an article about fire safety in various magazines and published a book called The Missing Link on electrical safety. I do not want to take much time, and the purpose of this learning from losses, ladies and gentlemen, is we almost lose 36,000 crore economic loss due to electrical fire is almost 36,000 crore in a year, apart from losing lives. And the previous year, the government shut 4,800 units, which was violating the electrical best practices or violating the safety norms. They shut around 4,800 units. When there is a fire occurs in a building, the first person to go behind bar is the facility head and the owner of the property. As we all know, it's a non-bailable, minimum of 6 months prison till the report is released. The mental agony and the financial losses, and to put back the business back into action, it takes a couple of years once there is an incident happen. I have interviewed many people who had a fire, and there are most of the 75% of them are still yet to recover from the shock. Not shock just because of this fire, the impact after the fire, the reputation of the organization, reputation of the person. Because these things happen because of ignorance, lethargy, or a chaltaya attitude. Nothing's going to happen to me. But they don't know what it will cause them once there's an incident is reported. So today, our speaker, Gopakumar, is going to talk about why this happens, why we still do not learn to do a best practice in electrical installation, are we doing a good job in electrical installation? So I would like to welcome our speaker, Gopa Kumar, to take over from me and talk about, I want to excuse myself because I'm in a remote place where the internet is quite slow. So I'm doing this on a 4G. So far, I'm sure it's come uninterrupted. I'll remain with you. During the question answer, I'll come back. So over to Mr. Gopakumar. Thank you.
Thank you very much, Mr. Dominic. Good morning to all the participants. So, to start with, I would like to provide a subject. All of you are aware that our safety, electrical safety, the primary document is the safety regulations by the Central Electricity Authority. CEA measures relating to safety and the electric supply. That is the regulation. Now, a new regulation has been published yesterday by the CEA. I'm just showing you the screen, the website of Central Electricity Authority. You have to open the Central Electricity Authority. Then you go to this place, regulations. You look at draft regulations. In the draft regulations, you can see the draft Central Electricity Authority measures relating to safety and electric supply regulation 2022. This regulation is very important because even today we use the IE rule, Indian Electricity Rule 1956, which is obsolete, which is not valid anymore. The 2010 regulations had come up, and now this one, 2022 regulation, this will supersede the 2010 regulation. So if this regulation is gazetted, then this is going to be the regulation for India, or all electrical engineers are supposed to follow these regulations. So you can download this regulation. If you press, you can download the regulation. The important subject is, I request all the participants, please read the regulation, understand it, and if you have any comments, please write to CEA, because this is the right time to inform about our points, or the people points to the regulator, so that they can include or they can add value to the regulation. Please do it. Now, to start with today's webinar, today's subject, I will stop the video for some time. So today's subject is learning from losses, electrical safety and fire due to short circuit, learning from losses. You see, I am not going to talk about the general incidents which is creating fire. For example, in Delhi, 2 weeks back, there was an accident and 27 people passed away. So it was reported that the fire started from the generator, which is kept at the first floor of this particular building. All of us know that we are supposed to keep certain minimum safety measures, such as, for example, if you have an oil-filled transformer, you have to keep it a little bit away from the transformer, away from the building. Recently, I even saw a building where the oil-filled transformer is kept on the rooftop. So the rule says you should keep it 6 meters away from the building, but we don't follow it. Similarly, DGs, you have to keep it outside, or you have to keep it in a very well protected, ventilated place, but DGs are kept at higher floors and with very less ventilations. And all of you knows the condition of wires running in our buildings without any support, hanging bunches of cables. I am not going to talk about that subject as well. So instead of talking about the subjects which all of us knows, I wanted to take you to some subject which is sometimes neglected even by an expert electrical engineer. So we will be going a little bit deep into the subject. All of you knows very well that Cape Electric, we are doing business in electrical safety. We have lightning protection, we have electric and enclosures, and we are into EMI, EMC as well. We are a 25 years old company having 200 plus employees. And we do the global earthing system, means earthing system which is for interconnecting, or which interconnects extra high voltage, low voltage, high voltage all together for modern industrial and commercial buildings. And we do parallelly, I think about 250 projects are running across India. So now coming to today's subject. The Mumbai Fire Brigade, or from the news from Mumbai, says approximately 80% of the fire accidents are from electrical reasons. Of course, electrical engineer always don't accept this claim. They say that there is no record, or there is how can you conclude that 80% fires are from electricity. But as an engineer who has visited hundreds of sites for electrical safety audits, I would even rather call us, for in some buildings, even 100% fire could be from electrical reason. That is the way the electrical safety is looked by the electrical safety engineer. So the situation is not really good. As I said, I am not going to talk about the general violations like keeping the DGs inside the building, keeping the transformers, oil-filled transformers inside the building, making very poor wiring, wires hanging everywhere, switches outside, junction boxes open. So these are very well known to us. I am not going to talk. I'm going to talk something little bit different. All of you know that in an electrical installation, you need different protective devices. The first one is OCPD, overcurrent protective device, nothing but our fuses, MCBs, MCCBs. The name calls OCPD, overcurrent protective device. It means whenever there is a current more than its capacity, this device is supposed to trip. So with this name, a lot of engineers believe that if you use a 10 amps MCB and if the current is 11 amperes, it trips. Or if the current is 12 ampere, 13 ampere, it trips. Of course, sometimes it trips, but it takes a lot of time. So not only the disconnection current, but disconnection time is also equally important. Now in an OCPD, especially for, let us say, for example, an MCB, there is a conventional disconnection time and conventional disconnection current, which is very much important. In a general situation, conventional disconnection current is about 1.45 times its rated current. And if the current is up to 1.45 times, an MCB can take up to 1 hour to trip. We always should keep this in mind. Of course, these protective devices are supposed to protect the cables of that particular circuit. It is also supposed to protect against earth fault in case of an TN system. Then we have protective devices such as residual current devices. We have arc flash detection device, and we have SPDs, surge protective device. So in our network, we have different kind of protective devices. And if these devices are selected and erected appropriately as per the recommendation of the standards, for example, IS 732 or the upcoming National Electrical Code, you can be sure that the chance of fire or chance of accident is reduced drastically, very, very minimum. So if you look at an MCB, just for your understanding, there are 3 types of MCB: B type, C type, and D type. Both the B, C, and D, once when the current is 1.13 times IN, that means at 10 amps MCB, if the current is up to 11.3 amps, this MCB need not have to trip. No need to trip, because it is designed for that. If the current is up to 1.45 times the IN, as MCB up to 63 amps, it can take about 1 hour to trip. And for all OCPDs above 63 amps, it can take up to 2 hours to trip. We always should keep this in mind. It means in a 100 amps circuit, if the current is about, let us say 140 amps, and you are using an MCCB, up to 140 amps for 2 hours, your circuit and the connected load are supposed to withstand basically. So we should select and erect the wires in that particular fashion. The installation must withstand that much current and that much duration. If the current is up to 2 or more than or equal to 2.55 times approximately, then an MCB of up to 32 amps trips within 1 second to 60 seconds. And in case of higher than 32 amps, 1 second to 120 seconds. These are the disconnection time. Now, in a type B MCB, if the current is 5 times the IN, it trips within 0.1 second. C type 10 times IN 0.1 second, then 20 times IN, again, the disconnection times are quite quicker. So when we select the devices, we have to keep this particular parameters very much in our mind. Now, we always think that the electrical panels, all of us knows how a panel looks like, how a distribution board looks like, how the energy meters are installed, how the systems are appearing in our network. In 2015, I was in Bombay, in somewhere close to Worli, and I saw an electrical installation, something like this. You will be surprised to see what exactly it is. I was told that this is an open switchboard. It is inside a room, and the room is having a door and a lock. So it is in locked condition. But unfortunately, the lock was with the security man, and he was opening it up, and he was going inside this room as and when he required. And this is like a meter room, and with a lot of fan, because the bus bars and the devices are hot. It is getting heated up. In order to cool down, fans are used. This was in 2015. Even in 2017, this building existed, this installation existed. I don't know the current situation. Now, when we met the owner of the building, we asked, why are you keeping in such a bad situation? Then he told, no, this belongs to the energy supplier, electricity supplier. I was actually shocked to see this kind of an installation made by the energy supply company or the electricity board or the utility inside the customer's premise, which is a little bit a 4-floor or 5-floor building, and this is on the ground floor or in the basement. You look at the situation, and what is funny is, look at this area, it's wet. This place is wet, and there was smell of diesel. I suspect that the diesel for the DG is also kept inside this particular room. If we operate our electrical installation in this fashion, or I would say this is one of the worst installation I saw in my life, and this belongs to an utility. And if this kind of an installation exists in a city like Bombay, even in 2022, it's not a surprise to say that 80% fires are from electricity. I would say even 100% fires are from electricity if we go for these kind of unsafe installations. It's highly dangerous. The best thing what we can do is, I request the fire department probably in Bombay, please open the meter board of the multi-story buildings, and if you see these kind of installations, you can certify that these buildings are not fit for occupation. That is the only way which can stop these kind of such a bad installation. So what I wanted to tell you is, it is not only the DG or the transformer which is kept inside, but such very bad practices are also made inside the building. It's really dangerous. Please don't do it. The second subject, one moment. I wanted to hide the floating. Yeah. The second subject is improper switching of neutral and the backfeeding. All of you knows that we have the habit of using inverters in our houses. Normally, what do? We take either the input or the output of the inverter. You can see only one phase coming out. Probably one phase goes inside and one phase goes outside. But for the operation, of course, there is a neutral as well. But the point is, there is a common neutral which is shared between all the loads. So the neutral is not routed properly along with the phase conductor. Neutral is looped from the common. This kind of installation, what happens is, whenever there is a switch off condition, whenever there is no power, and once when the power is fed from the inverter, there is a high chance of backfeeding. And this backfeeding, it goes into the line, and your neighbor probably may get electricity, or probably somebody working on the high voltage line, he also gets electricity. And as a result, a lot of accidents are happening. A lot of people, especially people, engineers or the technicians working with the distribution companies, are getting electrocuted because of this reason. What is actually recommended is both the phase and the neutral has to be isolated. That means your inverter, the circuit which is fed by the inverter, shall have both the neutral and the line conductor either from the inverter or through the bypass. So you cannot loop neutral just like that. Take the neutral from the neighboring circuit and use it in your circuit. This is actually illegal. You cannot do that. So if you are using an inverter, please ensure that you are using this kind of an installation, and the inverter or the UPS is able to isolate both the line and the neutral. Otherwise, this is a reason for accidents. Actually, inverters with single pole switching is a violation of safety standard. There is a picture in IS 732. We have also made this kind of a picture in an upcoming document. So you can see it probably very soon in the National Electrical Code. We know that we generally use, the isolation transformers. Every electrical engineer, those who are working in the industrial and commercial premise, larger buildings, they always say that neutral earthing, I need a separate neutral earthing. I have a isolation transformer, it requires a separate neutral earthing. Actually, there is nothing like a separate earthing in electrical engineering. So the only cases, in case of a TT system, you can have a separate electrically isolated earth electrode. Otherwise, in a building, in your building, in an installation, all the exposed and extraneous conductive parts must be interconnected. That is the earthing. Now, here the picture I took from the IEEE 1100. You can see this particular picture. See the ground wire which is coming connected to a common point. The frame is connected to the common point. The electrostatic shield is connected to the same point. And now the outgoing ground wire and the body are connected to the same point. And what you should see is, see here, the neutral, the star point of the transformer is also connected to the same point. So basically everything is interconnected in one common bonding point. This is the correct way of installing and using an isolation transformer. Why I explained this slide is, once when we go into deep, after a few slides, you will be able to find out the system, the difference between actually a recommended system and the system which we use. So UPS, which is always a very critical subject in our usage, electricity usage, because we have a lot of power cuts, and as a result, we use a lot of UPS. Now, I took this picture again from IEEE 1100. IEEE 1100 is a recommended practice for grounding of electronic installations. Especially, there are 8 type of installations or UPS explained in this particular standard. Now, this is a single module UPS, a non-isolated bypass and grounded Y connection. So don't look at the entire picture. It takes a few minutes for you to understand. Just look at what is shown in this red color box or red color ring. So the inverter output is having an electrical separation. There is a star point, and the star point is the neutral. So inverter output has got an electrical separation. That means whenever the output computer loads are working from the inverter, this supply is electrically isolated supply. It is an isolated supply from the transformer. So here another configuration of UPS, a single UPS model with isolated bypass. Of course, on the isolation, there is an isolation transformer, which is on the bypass circuit. Here you can see the transformer is delta star transformer and the star point is grounded. Now this grounding is coming, and you see in the UPS is also having an electrical separation. The neutral is connected to earth. Inside the UPS, the neutral is connected to the earth. Where I am scrolling I am showing the pointer, that is neutral earthing. It has nothing to do with the earth pit. Please understand. Now, this grounding, the grounding terminal or the earth terminal is further connected. That is a different case. This has nothing to do with the neutral. This has a common equipotential bonding. But where you connect the neutral is the earth terminal. I am showing another configuration. There are 8 configurations shown in IEEE 1100. This is a single UPS module, non-isolated bypass, isolated distribution center. In this particular case, you see the neutral, which is either coming from the input side or from the star point. It is terminated there. It is not extended to the load. So at the output, you have another distribution transformer. There is an isolation transformer. The neutral is connected to the ground terminal, the earth terminal, and it is earthed. So this is one of the configuration. Here is another configuration with a bypass, but module type UPS. You can see UPS module 1, UPS module 2. Everywhere there is electrical separation. And most important is at this point, the neutral of this UPS is earthed. Neutral is connected to the earth bus bar. This is the correct way of using an UPS. Now let's see what happens in our nation. What do we do in India? I'm not saying that this is happening in everywhere, but this is happening in some places. Probably 50% of our installations in office buildings, especially IT and commercial installations, we do in this fashion. For example, you are seeing a transformer, the 3-phase neutral and the PE conductor comes from the transformer. Of course, we don't have the PE conductor. That itself is, we use a kind of a TT system. There is no earth fault return path to the neutral of the transformer in our installation. That is also a violation of our standards. Now, don't look at that particular part. Now you look at the UPS. UPS is a 3-phase input and 3-phase output. So ROIB goes inside the UPS and it has got an output ROIB phase. And now, if the load is 3-phase, this circuit is perfect. Remember, if the load is 3-phase, because your UPS output is 3-phase and you can connect it to your load and the things work perfectly. This is a safe system. But in office and industrial premise, we often have single-phase load, especially computer load. So what people do is they use a 3-phase, an UPS with 3-phase input and 3-phase output, and take the neutral of the transformer and share it to the load. The common neutral, which is coming from the input, it is taken and it is connected to the single-phase load. Now this circuit itself is totally a disaster. Often I don't understand how this system works. That is a different scenario. But now this is how we use in a lot of installation. Common neutral is shared for single-phase equipment. From outside, from the load point of view, it looks okay, but it is not at all safe for whenever there is a overload or a short circuit in the load, it will be a disaster. It can catch fire. Now, anyway, this kind of a circuit, it cannot operate, or probably it may operate if the load is completely, if there is no neutral current. That means if the load is completely balanced, then this kind of a system may work. But whenever there is an unbalance in the system, or whenever there is a neutral current flow, what happens is the voltages of the system starts dancing. It completely changes, and it will start with the harmonics, and a lot of issues are going to come. Now, engineers found out a solution, and this solution is more interesting to understand. This neutral near to the UPS, they take a wire or a bus bar and run it probably 50-60 meters and connect it to an earth pit in soil. And they say that this is the neutral earthing of the UPS, or the neutral conductor, which is running inside your installation. At some point of time, some place it is taken out and connected to an earth pit in soil. And this earth pit is always isolated from the other earth electrodes. That means it is separate from the earth electrodes. So if you connect this to the earth electrode, something happens. This is what people think. Actually, this is a total violation of electrical safety requirement, and it's really a big danger. Neutral current will circulate everywhere within the installation. It will flow through every metallic part of your building, and it will create a shock, fire, and electromagnetic interference. So this kind of wiring is absolutely wrong. In addition, harmonics is another bigger issue. The people start using modern devices to reduce or to nullify the neutral current, and a lot of exercises are going on. But the very simple subject which you should understand is this is a violation of electrical safety requirement. Now, the last one. Remember, within the installation, neutral to PE, insulation resistance is minimum 1 meg ohm. What do I mean is, so from this place where I am making this red color round, this is your installation. Before that, you have the transformer. After that, you have the installation. Within this installation, you have 4 line current carrying conductors, 3-phase and neutral. Then you have a PE conductor. So here you have 3 + 1 current carrying conductor and a PE conductor. The minimum insulation resistance between any of the, not only any of the current carrying conductors to the earth conductor PE shall be minimum 1 meg ohm. This is a basic electrical safety requirement, which is if you wanted to know where this is written, you can refer to the IE rule 1956. You can refer the CEA regulation 2010, I think regulation number 33. Then you can refer IS 732, you can refer IS 3043, everywhere this is written. The minimum insulation resistance for a healthy operation of an electrical installation between the earth wire or the earth conductor, or let's say earth, and the current carrying conductors is minimum 1 meg ohm for a 230 or a 400 volt line. Once when the operating voltages are higher, of course, this insulation resistance also has to be higher or lower depending upon the operating voltage. So connecting this way, as I said, this way in the sense, this kind of a connection of a neutral to a separate earth electrode in soil, it is a violation of electrical safety requirement. Then what do? You have an UPS. If the UPS is having a 3-phase output, and if you wanted to connect a single-phase load, you please use an isolation transformer, and the isolation transformer neutral must be earthed in this fashion where I am showing. You have the 3-phase output from the UPS, then you have an isolation transformer. So it is electrically separating the circuit, load circuit. Then you have 3-phase, there is a neutral, there is an earth conductive conductor, P conductor, neutral must be connected to the earthing in this fashion. This link is the neutral earthing. This has nothing to do with the earth pit in soil. If the loads are single phase, use an electrically separated supply. This is the only accepted and safe system for earthing of UPS, especially when we use single phase load. And you also shall not forget that neutral shall run parallel to the phase conductor. Please don't make any daisy chain or don't loop it from the other circuit. P conductor also shall run parallel to each phase. Don't loop it from the other circuits, especially in computer loads. So this particular picture which I am showing has been included in the National Building Code 2016. How to use or how to make a wiring. For example, you have an isolation transformer. The incoming P conductor and the outgoings, all the P's are connected together in a bus bar. All you can see here, all earthing connections made at a point. Then please note that the phase, the neutral and the earth, to every socket, these are running parallel. We are not looping the neutral or the earth conductor. This is the correct way of providing power supply to computer or electronic installations. But as I said, about 50-60% of the places there are violations. Of course, the designer makes a design like this, but the contractor, while installing, he will be, in order to save the cost of some few piece of wire, they make a daisy chain. This is the reason. The testings which is mentioned in IS 732, I always used to tell there are 18 inspection points and 10 testings. These are very much important, so that in case of any mistakes, especially these loopings and all, we can very easily find out and we can rectify those defects. Now, UPS, the recommended ways of using UPS. If you have an UPS with the internal electrical separation, you can use the UPS for your single phase load. If your UPS is without electrical separation, that means there is no isolation transformer internal, then we are supposed to use an isolation transformer either at the input of the UPS or at the output, something like this, which is shown in the figure. And this is UPS without a bypass channel, with the direct channel and reversible UPS. And if you have a UPS with isolation or with bypass channel, this is the way we are supposed to use. The first picture, the rectifier battery and inverter module with internal electrical separation. Then for the bypass, you can use the bypass channel, you can use the isolation transformer. And these are the other configurations. You can see those configurations in that IEEE 80. Now, the next subject, neutral to earth voltage. All of you knows very well that, especially in industry, people always, electronic engineers always say that neutral to earth voltage, more than 1 volt, more than 2 volt, more than 5 volt is a problem, and we need to reduce the voltage and we need to, otherwise the electronics are failing and so on. What is this neutral to earth voltage? I'm just showing a simple circuit. On the right side, you have the source, you have the main distribution board, you have the sub distribution board, you have the final equipment. Imagine through the neutral, there is a current flow, let's say 10 amperes. As a result of this current flow, if we look at the source, near the source, the neutral and the earth, I'm talking about a TN system, the voltage is 0. Little bit away from the source, probably the voltage is 2 volt because there is a small voltage between neutral and earth, and near to the equipment, probably the voltage is about 5 volt. And this 5 volt, from where it comes? It comes because of the voltage drop in the neutral conductor. Technically, this voltage has nothing to do with earthing. This is the voltage drop in the neutral conductor. Now, in the industry, people used to demand that more than 1 volt is a problem for my electronics, and they are not ready to work with more than 1 volt between neutral and earth. As a result, what the electrical or the engineers do is they make a loop between neutral and earth. So here, where I'm moving the cursor, the neutral and earth are connected. This is actually a violation of the electrical safety rule. The rule says downstream main distribution board minimum insulation resistance to PE shall be greater than or equal to 1 meg ohm. So here you have where I'm moving the cursor, you have the main distribution board. From there, downstream up to the equipment, the minimum insulation resistance is 1 meg ohm. If you make a connection, if you earth the neutral downstream, then this rule is violated. So the interesting subject is now there are some gadgets available in the market, which is called as digital grounding device. It's very funny to understand what exactly these devices do. The manufacturers, there are some manufacturers, especially from North India, they come with a big story and a big, a beautiful catalog. It's a magic device which makes a neutral to PE voltage less than 1 volt. This is what they claim. And they also say that we are using an LC circuit internal inside the box to connect between neutral and earth. So this device will absorb the neutral current. This is what they say. But let us look at what is the rule. What is the minimum requirement? Maximum protective conductor current. What is protective conductor? Protective conductor is the earth wire. Earth wire, it is not a current carrying conductor. It's an earth wire. It's a dead wire. For load up to 20 amps, you see the maximum allowed leakage current or maximum allowed continuous current in the PE conductor is 10 milliampere. So there is a limit for the continuous current flow through the earth conductor. So the IEC 60364 says the protective earthing conductor should not be used as a conductive path for current under normal operating condition. Of course, during fault it can flow, but not during the normal condition. When the current exceeds 10 milliampere under normal operating condition, a reinforced protective conductor shall be used. Basically, we are supposed to make additional safety measures, but don't look at the slide on that way. What is important is the maximum current which can be used or which can flow continuously in a PE conductor is few milliamps. Or now look at the digital earthing. I would say it's a digital disaster. So this was the picture in one of the customer premise. I attended a presentation made by one of this company. So they show that this is the picture of the digital grounding device. It's very funny. Actually, if we look seriously into this circuit, you will be able to see that this circuit itself is wrong. It won't work. So basically, he has got some MOVs and some chalks and some GD tubes inside this black box. And they say that you see here, electrode, heat wire, catalyzer, electrode, even he don't know what exactly they are talking about. Basically, this product looks like a black box. So you see here EN, earth to neutral, less than 1 volt. That is his claim. And he also claims a lot of things. The manufacturer claims it's a static charge eliminator. It reduces neutral to earth voltage less than 1 volt. Detects surges and convert it into heat energy and dissipate through low impedance ground. Equipotential bonding to all equipment and improve earth resistance. Electrodes inside which will dissipate neutral current. Actually, this product comes with a beautiful catalog which contains a lot of claims. So what we did is, and basically this box looks like in this picture. It contains a black box. We don't know what exactly inside. There are 2.5 square mm wires coming from the 3-phase and the neutral through a 63 amps 4-pole MCB. This equation is also not understood. How come 63 amps MCB for a 2.5 square millimeters of wire? We don't know. Then there is a large bus bar, as I'm showing here on this picture. I'm sure you are able to see the cursor. All the earth wires of nearby equipment are connected to this particular bus bar. And what we did is I checked the resistance between the neutral and earth. Actually, they are internally, they are shorting the neutral and earth. The neutral and earth is simply short circuited. So in this particular case, without this digital disaster, neutral current is about 10 amperes. After connecting the digital disaster, neutral current is reduced to 5 amps because 50% of the neutral current flows through the neutral wire and balance 50% goes through the earth wire. The earth conductor current was 5 amperes. The electrical safety rule says maximum earth conductive current is about 10 milliampere or few milliamps, 10 to the power of -3, whereas here 5 amps current is going about how many times more than what is in the recommendation. So this is how it is used. They have a source, they have the main distribution board, sub-distribution board, and exactly in this particular location, after installing the digital grounding device, the potential between neutral and earth becomes 0. Actually, this is a complete violation of safety measure. Digital grounding device could create serious safety hazards. Neutral current to P creates problem to electronics used in these circuits. So what I recommend is, if you are by mistake, if you have purchased this device and if you have already installed it, my humble request is, please disconnect these devices if you are using it. Please immediately please disconnect it, because these devices will create more trouble to you. An electronic equipment can work even if the potential between neutral and earth are higher than 1 volt or even 12 volt. In an electrical apparatus, the neutral to earth voltage, even if it is a 30, 40, 50 volt, nothing happens to your equipment. Remember, this voltage, neutral to earth voltage, 0 or 1, is applicable for only for an earthed network. If you go for an unearthed network, such as an IT system, then the neutral to earth voltage can go up to 230 volt. All your equipment are designed to work up to that particular voltage. I mean, even if the potential between the neutral and earth are 230 volt, your equipment are supposed to work. Now, if you have functional earth, which we also call as isolated earth for the electronic equipment, the way of handling is different. So you have to have a functional earthing system. It has nothing to do with the safety earthing system. So this is actually, so the simple recommendation is, if you use digital grounding device, please disconnect it immediately. Of course, I know that you must have spent a lot of money for these particular devices. Of course, the easiest way is please disconnect it. Otherwise, you will be in much deeper problem. So I just show you a picture, a video. I'm showing you a video of an explosion. During the last program, when I show the video of the earth electrodes or something on the ground exploding, there was a big discussion. And now here you see that was an explosion from the panel board. I will repeat the video again. Once when it is 33 seconds, then you will be able to see the explosion. What has exploded in this panel board is an SPD, surge protective device. The SPD which is installed inside, it has burned. It's a petrol pump. not in a normal place, and you can also see where it is installed a little bit on this particular video. You can look at this place, so you will understand which company it is. So what has happened is the explosion from an SPD. SPDs, called as surge protective devices, are voltage operated devices, and these are connected always in parallel, not in series. It's connected in parallel, and any voltage more than the rated voltage is a little bit risky for these devices, and it may fail. Especially voltage such as TOV, temporary over voltage, are risky for these devices. The different reasons for TOV are a fault in the high voltage system, a fault in the low voltage system, or loss of neutral. That means in a three-phase network, if there is no neutral, or if the neutral is disconnected, you will have this kind of a situation. In this case, where particularly this explosion happened, the neutral from the petrol station to the transformer was disconnected the previous day, and some of the circuit breakers tripped, and without realizing the neutral disconnection, they tried to switch on the the panel board, and it exploded. Now, how does it works? I'm just trying to explain it through a single line diagram. You can see a three-phase and a neutral connection. Now, between the lines, you have 400 volt, and between the lines to the neutral, you have 230 volt. But imagine here you have a single phase equipment connected. We have three SPDs connected between line and neutral. So in normal condition, everything is perfect. Imagine a situation when there is a neutral disconnection. What is neutral disconnection? Very simple. There is a neutral wire has just broken. Under that condition, the potential between this connected load, a single phase load, and the neutral, of course, it becomes zero suddenly. And the potential between that neutral with the other phases becomes 400 volt. Please understand that I am explaining in a very simple way, because we also have some participants, those who are non-electrical engineers. So between that neutral and the lines, suddenly the voltage is 400 volt due to this neutral disconnection. And what happens is these two SPDs connected between the L1 to neutral and L2 to neutral, they are stressed with a higher potential for a longer duration, and it explodes. These kind of explosions was happening in a lot of places in India. A lot of failures had happened in the past. So this 400 volt stress on SPD will create failure and fire in the SPD, of course, which may spread through the panel board, and it can be fatal. So in the IEC, which is for the SPDs, during 2014, a new rule, the modification has come. The SPD and the backup fuse. Backup fuse means every SPD will have some kind of backup protection, maybe a fuse or an MCB. The SPD and the backup fuse will be tested with a TOV, and we can expect three results. The three results are, first one is fire and explosion in an SPD. Second is SPD may fail, but in a safe condition. The third is the SPD and the MCB, it will withstand. There are three results expected. The first result is dangerous because the SPD is catching fire, and these kind of SPDs, the manufacturer is not supposed to sell in the market. Of course, which market is the question. Europe and America follow this very seriously. So the SPD manufacturer cannot sell these devices which is creating fire and explosion during a TOV. The SPDs only fail safe or withstand, SPD withstand during TOV. Only these two are supposed to be sold in the market. Why I am stressing this point more and more is, even today, a lot of SPDs sold and installed are not tested for this parameter, or these are based out of this the first category. In case of any TOV, of course, you will be in deep trouble. People may ask, what is this SPD? SPDs are surge protective device. There are three categories for a power line application: type 1, type 2, type 3. These are the SPD categories, but we also have the names class B, class C, and class D. Actually, it's an invalid name. Don't look at it. The correct name is type 1, type 2, type 3. Where do we use a type 1 SPD? At the main switchboard. Type 2 at the sub switchboard. Type 3 closer to the equipment. So these are the devices, the culprit which created the explosion as per that particular video. Of course, there are several categorizations of SPDs. I don't go into it much. What you should select or what you should understand is always use the combination of SPD plus backup protection. Either this combination is able to withstand the TOV or fail safely during a TOV. If this test is not mentioned in the catalog or if this test is not carried out by the manufacturer, please don't use these SPDs. It's actually will create its own problem. The next point which I wanted to cover is, as we said, our subject is learning from the losses. Lightning protection is also a big subject of discussion. All of you know that lightning protection has to be done, carried out as per the IS standard, IS IEC 62305, and how it looks like is, imagine a building with a flat roof. So at the roof, we are supposed to make a grid of a typical size based on the lightning protection, class of lightning protection. And if you have some kind of electrical items or something above the mesh, then you have to have a rod individually to protect these items. So basically, you have to have an air termination system. A typical example is a grid of 15 meter by 15 meter and a few rods to protect solar PV and a few rods to protect the air conditioners, and basically equipotential bonding between the grid and the other items. This is how the air termination is made. For making the air termination, we can use the rolling sphere method, electrogeometric method, or the mesh method. Now, the second part is down conductor. Let us say in this particular case, 10 down conductors are required, something like this from the top to bottom. 10 down conductors are running as straight as possible. And finally, all these 10 are connected to the earth pit or earth electrode through test links. Now, the equipotential bonding between the down conductor and the MET. MET is a part of your electrical installation, the earth bus bar in the mains terminal or in the main distribution board. You are supposed to have an equipotential bonding here. This is very important. Of course, in most of our installations in India, this is not existing and people don't allow to connect this way. Actually, this is very much mandatory. And as an option, you can also go for a type B earth electrode. So basically, it consists of lightning protection consists of a mesh at the top, several down conductors, a ring earthing or individual earthings, plus an equipotential bonding to the MET. So this is how it is made. Now the subject here is, you see here, there is a subject in lightning protection which is called a separation distance. What does this mean is, at the location here where I am highlighting at the bottom, you have an equipotential bonding. Whenever there is a current flow through the down conductor, due to the surge impedance of the conductor, there is a high potential created where I am marking the red. High potential difference between the down conductor and the metal parts in the building is created. So how do we do that? There are calculations given in the building. In the standard, we have to calculate the separation distance, and basically all these down conductors must be kept away from the building. So if, for example, the separation distance 1 meter, so the down conductor must be kept away from the building. This is a mandatory requirement. Now, what do we do? Exposed LPS for high-rise buildings are dangerous. In a large building, let us say you have a 20-floor building, and do you think that an air terminal you can keep 1 meter away from the building, which is really impossible. You cannot do this. So the recommended way in the standard is to use a natural down conductor, means use the structural steel for down conductor. And in India, people used to call this as integrated lightning protection system. So for high-rise buildings, you have to have a air termination, you have to have down conductors running through the columns or inside the rebar, inside the columns, and finally the earthing system and equipotential bonding system. This is the correct way of earthing. But unfortunately, 90% of the buildings in India are not conforming to this, and they go behind a lightning protection system, which is called as ESE, early streamer emission. Typically, this installation looks like, imagine you have a multi-storied building. There is one rod, there is a down conductor connected to the earth pit. In an industrial shed, there is one rod, a long down conductor connected to one earth pit. And always this down conductor is a 70 square millimeters flexible copper wire. And the earth pit, sometimes it's a pipe or a tube or a plate, or sometimes 2-3 plates and so on. So this is how lightning protection is installed in India. In high-rise buildings, this down conductor it is even running through the closed shaft, and often it is running through the electrical shaft, which is a violation. Now, typically it looks like this. You have a building. There is one rod which the manufacturer says it is protecting not only your building, it protects the entire your neighbors and probably the whole village as well. And they call this as modern technology, advanced technology, and very, very attractive names. The claim is it protects one rod, protect hundreds of meters. It has got a counter, so whenever there is a lightning, your counter will count 1, 2, 3, 4, 5, 6 like that. And the most interesting point is if somebody says this is not correct, this installation is wrong, or ESE is a wrong method, then immediately the manufacturer says, no, it is accepted in the French standard, it is accepted in a lot of European standards, and they say that French people are not fools. If French can accept this system, why not India? This is the argument. Please understand how these installations are made in India. In India, it has got one rod, a simple 70 square millimeters wire running up to the floor, and then there is one earth pit. And then they claim this as per the French code. So this French code is available. English version is available for free download in some website. You just type NFC 17102, you can download this. Actually, this picture I took from the French code itself. It says there are 1 to 18 items required to protect a building. Serial number 1 to serial number 18. I don't want to go into deep. Now, if you look at the Indian standard or the IEC 62305, the IEC says your lightning protection, you need to have the item number 2 to 18. So item number 1 is not mandatory, or item number 1 is not required as per the IEC standard. The French standard says you need 1 to 18. So technically, by making this item number 2 to 18, your building is actually satisfied. As per the 62305, the requirements of 62305, your requirement is satisfied by serial number 1 to 18. But what the French standard says, you put an additional rod here. One more, you put an additional rod. This rod is an additional. Whereas when it comes to India, what the manufacturer says is you put one rod, one down conductor, and one earth electrode. What happens is, whatever explained in this particular standard, the French code, serial number 2 to 18 is missing. So basically, there are two questions here. Number one, the early streamer emission technology, the advanced or this 100-meter covering radius itself is not accepted anywhere. And the French code is made in a very clever way without violating the European rules. But what happens is these manufacturers take this book, come to India, and make a different story and sell these products in India. These products, of course, production cost may be 5,000 rupees, but the selling cost is 1 lakh rupees. It is also like the digital grounding device. Production cost is probably 10,000 rupees, but the selling cost is 5 to 6 lakh rupees now. So this is, I would say, is another disaster. Please don't do it. As I always show in my presentation, the 2016 report published by Mr. Honda from Japan in the CEA safety seminar, 12th April 2016. According to them, India lead the number of death, 723 per 100 million population per year. In comparison, you can see here 12 numbers in Japan. And out of G20 nations, we have the least electrical safety score. Even countries like Indonesia, which is not similar to us, here the score is quite less, quite higher than India. We have the least score. So to conclude, what I wanted to tell you is, on an outer phase, we can see a lot of violations. Like example, the transformers are kept, oil-filled transformers are kept inside the building, kept on the rooftop. The DGs are kept inside the building. The wires are hanging. The MCBs are not tripping, and so many things are, so many violations are there. But here, in this presentation, I just tried to touch upon some subjects which is in addition to the subjects which we were covering in all the previous programs. In each of our program, we are trying to cover some of the subjects. As you know, all the subjects cannot be covered in one go. It's a long subject. Now, what we are doing to handle this situation is, we have made a digital platform, solve safe operation of low voltage electricity. As you can see, safety cannot be achieved by installing one device. Safety cannot be achieved by testing your earth pit resistance. Safety cannot be achieved by testing the insulation resistance. Actually, you need to combine all the requirements, and you have to do everything. You have to completely conform to the requirements of the standard. So what we do is, we are very specifically going into the testing, inspection, and certification of electrical installation. The software guide our certified people how to make the testing or the inspection. And while guiding it, it also tells you some additional requirement. See, for example, the verification, generally, if we carry out through the IEC standard, of course, they are made with the European or the American perspective, whereas in India, the situation is entirely different. So we are actually Indianizing those requirements. So additional tests are sometimes required. And finally, it will be very easy to identify the future fault. We also do investigations. In the sense, whenever there is a failure, the software can be used for investigations to find out the probable fault or the probable reasons, and the software will help in designing little bit electrical safety measures for special application like hospitals, medical locations, and so on. So this software we started developing almost a year back, and now we have a big team of software engineers, those who are working on it. And we are trying to make it a little bit towards artificial intelligence, because now everything is with the computer. So what the services which we do at the moment is, we are giving a comprehensive electrical safety as a partner in electrical safety. As I said, electrical safety is not a subject which can be achieved by one product or one service. The first point is, the safety engineer need to be really knowledgeable. We have to have the clear understanding of the entire electrical system, starting from the transformer up to the last socket and the connected load, which will be very difficult at the moment for one person to keep in mind and make a verification or an inspection. That is the place where the software is really going to help. So what we started doing nowadays is like design support, training, and verification of basic drawings with respect to safety. We also do the checking of the installation, its compliance to standards, and we do support during erection. We do complete testing, inspection, and certification of the electrical installation. We take long-term contract and for periodic testing, and keeping the records for future, of course, along with the software in the computer or in the cloud. Plus, we also do PAT, portable appliance test, which is probably the future. So with this, I would like to stop the presentation. Thanks to all the participants. You can find out the details of our presentations in the LinkedIn or in the Facebook. You can also note down my email address and phone number. If necessary, you can also get in touch with us. We have a good team of about 200 engineers, those who are doing this particular job. Also, apart from the business, I am also a member in the IEC TC64 in the working groups or the maintenance teams, MT3, MT12, MT40. These are the individual groups, those who are handling specific subjects. Say, for example, MT40 is a technical group which is handling the or which is drafting or maintaining the standards related to medical locations. So similarly, TC81 for lightning protection, SC37 for SPDs. Then I am also involved in the National Building Code Electrical Committee and the ETD20 of BIS, which is handling National Electrical Code, IS732 and IS3043. So with this, I would like to stop the presentation and over to you, Mr. Dominic.
Thank you, Gopakumar. A very enlightening webinar that you conducted today, and many people, while you presenting, were chatting and appreciating the knowledge that you have been sharing. So every time it is learning that every engineer, as we say, there's no end to learn. So every slide that you show, there was a lot of learning. So I allowed two people to speak live, which Mr. Rajavelu Krishnan wanted to have a word with you. Mr. Rajavelu, if you can unmute and speak to a speaker, we can listen to you. Okay, before he comes online, let's take a few questions that is there on the box. Amrit Lal Nambiar is saying, you are referring to TN, yes, but usual supply from supplier is TT.
Yes, this is actually the biggest problem. The electrical utility companies, without understanding what is TNTT, they provide a TT system and they claim sometime it is TNCS or TNS. One of the fundamental mistakes which the electrical engineers make is this particular mistake. We are trying the best to educate the utilities to make the correct TN system. Actually, the utilities are violating the rules, violating the regulation. Very simple. In case of any accident, if the clients file a criminal complaint against the utility because they are violating the regulations, of course, the utility will be liable for the criminal proceedings because they are violating the rules. But who is going to make this kind of a complaint is the question. I would recommend at least if 3-4 such cases comes up, then the utilities will learn from their mistakes and they start improving. So to the answer, TT is not recommended in the standard or in the regulation. TN is recommended in the regulation, but as the final conclusion, the upcoming CEA regulation measures relating to safety and electric supply. The earlier regulation 42 for RCD, I think in the new draft it is 44. So if you look at that, the energy supplied to every electrical installation for a TT installation, 30 milliampere RCD is mandatory. That means the electricity supply company shall give 30 milliampere RCD as a mandatory rule for every installation if it's a TT. This regulation has got 2 paragraphs. The second paragraph says RCD is not required if it's a TN system. So somehow there is a solution from the regulator. Thank you for the question.
Thank you. Prakash Karla, you are there. You're unmuted. Your question should be specific to the slide that you have shown. Prakash, you can talk. Prakash Kalra, we can't hear you. Can you be louder? I don't know whether it's the same for everyone. Okay, I'll move on to Avinash Dosne. Is asking, earlier streamer protection are allowed. Are we still?
The question is, early streamer protection are allowed? No, they are not allowed. The National Building Code has very clearly written that these devices shall not be used. Unfortunately, 100% of the solar PV installations, these devices are used.
Okay. Nagaprasad Ganesh is asking, sir, please clarify where we should connect N and P together and where we should not connect.
Inside your, after the mains board, after the main switchboard or after the meter board, neutral and earth must be separate. I repeat, must be separate. And the minimum insulation resistance is 1 megohm. Now, neutral and earth can be connected together at the meter board or upstream. That means from the meter board towards the distribution transformer, you can connect. So 2 points you must understand that from the distribution board up to the meter board, or from the transformer up to the meter board, it is the utility, or it is the property of the utility for a LV client, low voltage customer premise. Inside the customer premise, it's your property. You must keep these two separate. In case of an industrial or commercial installation, from the transformer up to the within the installation, neutral and earth must be separate, except the neutral earthing. Only one location, strictly at one location.
Okay, Davies, are you able to listen to me, or can you hear me? You are allowed to speak.
Yeah, Mr. Dominic, thank you very much. And thank you very much, Mr. Gokumar. It was quite informative, quite enlightening session. So I think you have addressed a lot of topics. So I was just picking up some of the points which I wanted to ask you. So you talked about RCD, that is RCCB, we call it, residual current circuit breaker. And can you throw a bit light on AFDD, R fault detector device also you addressed there? That is point number one. And point number two, the neutral and earth, you have been very fantastically mentioning the voltage doesn't matter even if it exceeds 5 volt. So can you just give a little more information on this, Mr. Gokumar? And if the time allows, there are a lot of questions, but I know it is not the time
let's
doesn't
take
allow.
2 questions at a time.
Yeah.
Mr. Davis, since you are, we are a common member in the WhatsApp group, Vidyut Suraksha, probably you can also post these questions.
I will definitely, because some of the unanswered questions for quite long term of my 35 years are getting answered here. So thank you, Gokumar. Thank you.
Yeah, thank you. So the first thing, AFDD,
Yes.
arc flash detection device. It's a device. You see all the protective device like MCB, OCPD. It will trip once when there is a overcurrent. RCD will trip if there is a residual current. The SPD will protect if there is an over voltage. There is no protective device effectively which can disconnect the supply in case of a loose contact, especially once when there is an arcing.
Right.
Imagine in the background, for example, a lot of fire accidents are happening in India because of the fire from air conditioners, especially in bedrooms. AFDD is a device. Whenever there is an arcing downstream the AFDD, this device will trip. I don't know how it is working. Probably it is monitoring the sine wave, and there can be some electronics inside the device. Companies like ABB, Schneider, Eaton,
even
they are
Siemens,
making this.
Siemens also has
Siemens. Yes. So this may be probably monitoring the sine wave, and during arcing, of course, the sine wave is lost a little bit for a short duration, and probably these devices are disconnecting the supply.
Right.
So these devices are actually recommended in few critical places. You cannot put it on at every switchboard because it's not necessary. But for example, in the upcoming National Electrical Code, what is recommended is these devices can be used in sleeping accommodation, like that means the bedrooms, then places where you store explosive materials and some kind of such critical places you can use it. That is about AFDD. The second part of the question, the neutral to earth voltage, 1 volt. You see, electronic installation sometimes require two different type of earthing: safety earthing and functional earthing. Functional earthing is the new name. The old names are sometimes clean earth, isolated earth, and there are different names, but the new names are going towards functional earth. That means for the functioning of the electronics, there shall be a zero reference plane. So if the zero reference plane is perfect, communication will be perfect and all your electronics will work properly. With this concept, which has been adopted in the IEC standards almost 20 years back, in India, this functional earth concept or the isolated earth concept has been actually violated. What we do is we take a wire and the things are connected to a separate earth pit in soil, which is a violation. And with this concept, a neutral to earth voltage of up to 230 volt. That means we are talking about a 230-400 volt line. A neutral to earth voltage of 230 volt is immaterial for an electronics to operate. Now, how come a 230 volt comes between neutral and earth? Of course, if you have a isolated system, IT system, then neutral to earth voltage can go up to 230 volt. I hope I answered your question. But as I wanted to add one more, it's not a very simple thing to understand. The functional earthing itself, I can talk for 3 to 4 hours.
Okay, thank you, Davis. To Solomon Chandrasekhar was asking, thank you, sir. Could you please share any electrical safety lesson learned from disasters such as flood? Is there any study that is done?
Of course, this is another big point. Actually, in the IEC TC64, which is the low voltage electrical safety standards, Japan has proposed a new standard, a resilient electrical installation. That means, in case of a disaster, how fast it can be put back to service. Of course, with respect to the floods in India, if the electrical installation was under flood or underwater for a few some time, then be very careful. You have to really ensure that before putting it into service, you do an insulation resistance test at least. If you do the insulation resistance test, you are sure that the connected things are perfect. But during this test, I'm sure it will be very difficult to get the results, and you may have to dry up the entire installation. You have to put all the things perfectly, check everything. But the simple answer is you ensure that the insulation resistance of higher than 1 megohm is maintained, and then you can operate.
Okay, Ishwar, are you there? If you're listening, probably you can talk to Gopa.
Yeah, good afternoon, Gopu, as usual. It's a great session and it's enlightening us. One very pertinent question with regard to fire protection systems, especially, as per the codes, you're either required to provide a DG set or a diesel engine or an alternate power supply for changeover from primary to secondary in the event of outage of primary power. So in the event of outage of power supply, I'm just wondering if you can provide a correct and reliable method per codes for the automatic transfer of power from primary to, will be coming from substation 1 to an emergency power supply, which will be coming from substation 2. to cater to all the emergency load. It will be like the fire pump, sprinkler pump, booster pump, staircase and corridor lighting, maybe even the elevators, fire alarm system and PA system and pressurization fans. Because there is no sketch provided anywhere in any of the Indian codes, be it the NBC or the Maharashtra Fire and Life Safety Act. So it is just mentioned that you need to provide from an alternate source, which typically needs to be from a substation. I see that NEC and all, they have provided fairly copious information on this. So if there is something that you can suggest, then I can even request the fire authorities to incorporate it in the code so that people do it the right way. Otherwise, it's like any other black box that as you were mentioning in relation with something else.
Yeah. Actually, thanks for the question, sir. It's actually a serious subject or a very important subject. See, especially for the life-saving equipment or the life-saving service, continuity of the service is highly important. I mean, the supply to the life-saving equipment, to the pumps, to the smoke extractors, basically the electricity which is going to the firefighting system or the escape route system. There, as I said, or as I always say, the electrical systems are classified into two. Earthed system means your protective devices shall trip within certain time. Unearthed system, even under a fault, your system can work without, automatic disconnection is not mandatory or not necessary during the first fault. So the standards, especially if you look at the IEC 60364, the new ones, for fire safety or the safety services, IT system is recommended. IT means an unearthed system. There are different ways of creating unearthed system. If you look at only for the light fittings, emergency light fittings in the escape route, that particular power supply can be an isolated system. That means even if there is a fault, MCB need not have to trip. Plus, the wires used must be able to withstand a certain amount of fire for certain time. The light fittings has to withstand a certain amount of fire for certain time. So not only the backup supply, this whole installation shall support. Backup is one of them. Of course, changeovers, different kind of changeovers are recommended, instantaneous changeover, within few seconds changeover and so on. Actually, this is another big subject. Probably we can cover up in another full webinar.
Yeah,
So,
Ishwar,
Mr. Dominic,
you can probably tell me, we can do a webinar on the electrical supply to fire protection or a life-saving equipment. We will do that. If you can just send me a WhatsApp on that, we will do that along with our Gopakumar and others. Panel discussion on the importance of electrical supply to life safety equipment. So thank you for highlighting this, Ishwar. Vinod, are you there? If you are there, I will allow. Okay, come on, yeah.
Vinod. Good afternoon, Dominic, and good afternoon, Gopakumar. Pleasure to be on the program. Gopakumar, as usual, you're marvelous. It's always been great to hear you talk.
Thank you.
Again, this thing is on the protection of the devices which we use in the theaters and the hospital. It's quite a large subject, I know, but I just thought for the benefit of others and for me, basically, the protection of devices in talking about tripping or anything for equipment that we use inside the operating rooms in the hospital. Because systems have to function without tripping, but at the same time, we need to protect the patient also.
Yeah, if we are talking about this, inside the medical location, you see the technical name is medical location. That means in a hospital, group 1, group 2 medical location. So there, of course, continuity of supply is highly important, especially in group 2 location. There, IT supply is necessary. Plus, along with that, the touch voltage reduction measures lesser than 25 volt. That means a supplementary equipotential bonding is necessary as a mandatory safety measure. And places where you have oxygen enriched equipment or oxygen enriched areas, additional safety measures are also necessary. But as Mr. Vinod told you, we have to actually really work together to create some kind of documents for this at the moment. I have the documents from the IEC and the working technical papers, but for India specific, we have to make it because the standards made with an European perspective probably is very difficult to carry out in India. Over to you, Mr. Dominic. You are on mute.
Yeah, before I go to Tara Dal to allow her to speak, there are two questions I'd like to take. A quick question from Thomas Varghese. What is the allowed voltage between neutral and earth? Is it less than 1 volt?
There is nothing like that. There is no allowed voltage or not disallowed voltage and all. Voltage between neutral and earth can go up to 230 volt in an unearthed system.
Okay, John
So
Varghese
John
asking
Varghese is asking, yes, what is the reason for computer professionals to keep neutral voltage close to zero? I really don't know. That is not at all. You see, if you are talking about the neutral to earth voltage between the 3-pin plug, because your computer has got a 3-pin plug. If you are talking about the neutral to earth voltage between the earth pin and the neutral pin, absolutely not required. It can go even up to 230 volt.
Okay.
Yeah, over to you, Mr. Dominic.
Okay, Tara, if you can, if you can hear me, please speak.
Yes. Yes, thank you, Dominic, and thank you, Mr. Gopakumar. I'm an architect, so I cannot talk too much into detail as you delivered. But one thing is sure that we are designing some hospitals with a lot of equipments. Like say cancer hospitals are having a lot of equipments. And equipments have got their own calibration, have got their own specification of their earthing and all. So you have given a lot of advices on overcurrent, overvoltage, then surge protection, all these things. So how it can be, my question is, how all these safety parameters suggested by you, how it can be going along with all the equipment safety, number one. Number two, along with the equipments, because in cancer hospitals, very, very sophisticated equipments are there for the radiation therapy, for the nuclear medicine therapy. Sophisticated equipments are there, including the radiodiagnostics. And also in the same hospital, we have got operation theaters and ICUs. So the continuous supply of the power is required to those areas. So the safety to the patients and to the equipments related to the patients are also required. So these two things have to be covered up. Please answer.
Yes, sir. Yes, sir. Actually, for a medical location, not only the disconnection with safety by disconnecting the supply, safety by continuity of supply is equally important. Because the patient is in life safety equipment, and if the supply is disconnected, you will endanger with a bigger disaster. So there actually, number one, the installation shall, all these are actually very well documented in the IEC standards and ISO standards. For example, the equipment which you are using in your operation theater, I think there are about 300 plus ISO standards. Means each and every equipment which is used in a medical location, there are ISO standards available. Now, why I am talking as a standard? Because you are using some applied part into the body of the patient. So this applied part, the amount of the current which is flowing or the amount of the voltages which is created by the applied part has to be limited. For that, the first one is this equipment must satisfy the respective ISO standard. Number one. That means the equipment is safe to use. Now you connect this equipment into a room, an electrical installation in that particular room or an operation theater. This whole room has to satisfy the safety measures such as what is required for an oxygen enriched area, what is required for operation theater where the touch voltages shall be very minimum. Also, what is necessary to discharge the electrostatic field probably created from the different moving objects or from a person who is entering into the operation theater, plus touch voltage reductions, plus monitoring the insulation of electrical devices and so on. That is another big subject. Now, this operation theater is in a large building or in a building which consists of probably few sources, alternate sources, few large UPSs, and so on. So from the equipment onwards, the equipment must have its own, it must be tested and certified for its own standards. Then the installation shall satisfy its own requirement, and the whole building must withstand or must satisfy these requirements. As a whole, if we look at this complete subject, it is a subject which require a highly technical skill, and it's a big subject. But what I can tell in a simple way is, of course, there are written documents in IEC, in ISO. If we have a specific question, we can go through those standards and we can find out what is written and we have to follow. What we should do is, if we follow the IEC or ISO standard, don't try to violate it. Generally, what we do is, we read the standard, say for example, IS 732, somewhere it's written neutral to earth, the earth conductive current more than 20 milliampere is not allowed, but we neglect that. But such neglects are, it cannot be accepted. If we strictly follow the rules, please understand that in US and America, these standards are not mere standards, they are norms, these are rules. So we also should go in that way. But
Okay,
as a simple conclusion, it's not a simple subject which can be explained in 5 minutes. It's a very big and very deep subject.
Yeah.
Over to you, Mr.
Gopakumar, you said to Davis that you're part of the Vidyut Raksha. So there are a lot of requests coming to add. So I request participants who express their interest to join, Vidya Suraksha group. You send a mail ID is already mentioned. Your mail ID with your phone number and profile to Mr. Gopakumar. He will evaluate and probably he will take a call on that. So I would request you to email your profile and the contact details. So if you want to be part of the group. So continuing to our question, Priya Bratha is asking, solar panel installers are not bonding the earthing of the solar panel with nearest down conductor, saying it will damage the solar PV system. And it is a design, it's a design requirement. What is your opinion on that?
Actually, not bonding the earthing system of the solar panel with the nearest down conductor, that is not a design requirement. That is the perspective of the engineer, or that is the idea which went into the mind of the engineer. There is only one design requirement, which is equipotential bonding. The solar PV frame must be connected to the down conductor. It must be connected to the protective earth busbar or protective conductor coming along with the phase conductor and so on. The only exemption here is the DC, either the positive or negative, need to be earthed or not, is decided by the inverter manufacturer. Because finally it is decided by the way of protective measures implemented in the inverter. Otherwise, other than the positive or negative, 100% must be interconnected in a typical fashion. Don't take a wire and start interconnecting everywhere. You have to follow certain rules. Number two, at the output of the inverter, if you have a small inverter, single phase inverter, neutral, please don't earth it. You simply connect the phase and neutral to the power supply. That's it. No need to earth the neutral again.
Okay. Balasubramaniam, are you there? If you're listening, you can unmute and speak. Or Prakash Vishwakarma, if you can unmute and speak. Okay. I'll move on to the question from Ravindra Patnakar. In residential, many accidents were happened due to our geyser, fridge, iron box after using the RCBs of 30 milliamps, what can be used for the protections?
Actually, RCBs are protecting only against an earth fault. There are two safety situations or unsafe situations. So one is an overcurrent, means an overload or a short circuit, which is happening between current carrying conductors, means between a phase and a neutral. Imagine you have a geyser. The geyser is supposed to dissipate, let us say 100,000 watts. If the resistance decreases due to some reason, then the heat produced or the current will be over, and if the MCB is not tripping, of course your geyser may catch fire. Earth fault, or wherever we say fault means an earth fault. Earth fault is happening between a current carrying conductor and the earth. Earth is nothing but the body of the equipment, the body of the motor or whatever. So RCD is a device which will protect only against a over current, such as an overload or a short circuit. Sorry, OCPD, MCBs are efficient only for an over current, like overload or short circuit, and RCD is for earth fault or earth leakage. If you use a 30 milliampere RCD and for your geyser, if you put a very big size MCB, of course, during an overload, the MCB will not trip and finally you end up with trouble. So both the devices you should rate accordingly for your optimum design. So over to you, Mr. Dominic.
Okay, ladies and gentlemen, we are reaching 12:45. We have crossed our time limit. And if you look at the chat box, we have Mr. Gopakumar's email ID mentioned. Any further questions or queries on SOLV, that is safe operating low voltage electricity, please send a mail to Mr. Gopakumar. He'll be very happy to assist, or his team will come back to you. And we have many more questions lined up here, but due to our shortage of time, we'll not be able to take. Our next webinar will be artificial intelligence in electricity. So we will be having on 25th, and we will send you the mail requesting to register and join by Lakshmi, who is managing the whole at the backdrop. She will send you the link to you shortly. And I want to thank Gopakumar, in spite of domestic demand that you have on medical ground. I asked you whether should we postpone this webinar, but I know how closely you are for the knowledge sharing, and you've been very passionately doing this series on electrical safety. And I'm very humbled the way you come forward without any postponement. We conducted this event, and you're sitting in Trivandrum, and your signal was not strong at your home. You took a hotel to do this webinar. I'm so thankful to you. I'm sure everyone in this group appreciate your passion and support, Cape Electric, and also your digital platform on SOLV. And also I want to thank Lakshmi, who's behind the screen and trying to mention on the chat box about our website and details and the next webinar. Thank you all. Thank you for joining. Stay safe. We look forward to see you again for our artificial intelligence in electrical. So look forward to see you again.
Thank you, Mr. Dominic and all the participants. You can find the video or the report. We are posting as a blog in the website solvelv.com. I just put it on the chat box. So all the videos and the answers of the questions which we didn't answer today are also answered in the blog. Please go through it. Over to you, Mr. Dominic. Thank you very much, and thanks all the participants.
Blog link, have you shared here? Your blog link here in the chat box?
I will just put it.
You can share your blog link so people can copy that and start interacting with you. Yeah. So those who can visit solvelv.com/blog, Again, I'll repeat, it's a solvelv.com blog. So you will see many answers to your questions. Thank you very much. You have a great day. Thank you. Bye-bye.